At the end of this video, you should be able to describe how astronomers determine the compositions and temperature of stars. Chapter 30, Section 1, Characteristics of Stars. A star is a ball of gases that gives off a tremendous amount of electromagnetic energy. This energy comes from nuclear fusion within the star. Nuclear fusion is the combination of light atomic nuclei to form heavier atomic nuclei. As seen from Earth, most stars in the night sky appear to be tiny specks of white light. However, if you look closely at the stars, you will notice that they vary in color. For example, the star Antares shines with a slightly reddish color. The star Rigel shines blue-white, and the star Arcturus shines with an orange tint. Our own star, Sol, is a yellow star. Analyzing starlight. Astronomers learn about stars primarily by analyzing the light that the stars emit. Astronomers direct starlight through spectrographs, which are devices that separate light into different colors or wavelengths. Starlight passing through a spectrograph produces a display of colors and lines called a spectrum. There are three types of spectra: emission, or bright line, absorption, or dark line, and continuous. All stars have dark line spectra, bands of color crossed by dark lines where the color is diminished, as is shown in Figure 1 on the screen here. A star's dark line spectrum reveals the star's composition and temperature. Stars are made up of different elements in the form of gases. While the inner layers of a star are very hot, the outer layers are somewhat cooler. Elements in the outer layers absorb some of the light radiating from within the star. Because different elements absorb different wavelengths of light, scientists can determine the elements that make up a star by studying its spectrum. The composition of stars. Every chemical element has a characteristic spectrum in a given range of temperatures. The colors and lines in the spectrum of a star indicate the elements that make up the star. Through spectrum analysis, scientists have learned that stars are made up of the same elements that compose Earth. But while the most common element on Earth is oxygen, the most common element in stars is hydrogen. Helium is the second most common element in stars. Elements such as carbon, oxygen, and nitrogen, usually in small quantities, make up most of the remaining mass of stars. Temperatures of stars. The surface temperature of a star is indicated by the star's color, as is shown in Figure 2 on the screen here. The temperature of most stars ranges from 2,800 degrees Celsius to 24,000 degrees Celsius, although a few stars are hotter. Generally, a star that shines with blue light has an average temperature of 35,000 degrees Celsius. However, the surface temperatures of some blue stars are as high as 50,000 degrees Celsius. Red stars are the coolest stars and have average surface temperatures of 3,000 degrees Celsius. Yellow stars, such as the Sun, have surface temperatures of about 5,500 degrees Celsius. The sizes and masses of stars. Stars also vary in size and mass. Some dwarf stars are about the same size as Earth. The Sun, a medium-sized star, has a diameter of about 1,390,000 kilometers. Some giant stars have diameters that are 1,000 times the Sun's diameter. Most stars visible from Earth are medium-sized stars that are similar to our Sun. Many stars also have about the same mass as the Sun, though some stars may be significantly more or less massive. Stars that are very dense may have more mass than the Sun and still be much smaller than our Sun. Less dense stars may have a larger diameter than our Sun, but still have less mass than the Sun. At this point, you should be able to describe how astronomers determine the compositions and temperature of stars.